Okay, welcome to Atmospheres in Motion, Chapter 8, Part 2 for ESCI 211. So let's get started today. So today, I want you to have a better understanding of the forces that influence the winds, and there are four forces that will do that. We've already talked about the pressure gradient force. The other force is called the Coriolis force. Another idea the book calls centripetal acceleration, and another force called friction. So these forces will produce several types of winds. One of them is called a geotropic wind. The other one's called a gradient wind. And then we'll talk more about frictional forces and how air moves vertically in the atmosphere, and something called convergence and divergence of winds or pressures in the atmosphere. So let's talk about force. All right, all forces are controlled by an idea called Newton's second law, which states that a net force acting on an object should be equal to the mass of that object times the acceleration of the object. What is a force? A force is an interaction between two other objects. And what is an acceleration? Basically, an acceleration is the rate at which the velocity changes in time. So forces and accelerations that influence the wind is our pressure gradient force, our Coriolis force, what the book refers to as centripetal acceleration, and frictional force. So what is a pressure gradient force? Just like we talked about before, wind, or if you have a high pressure region and a low pressure region, the air will flow from the high pressure region to the low pressure region. So the way we write this is we got this upside down triangle here, right here, and that's called a del, or a gradient of capital P, which is pressure, right, is equivalent to your change in pressure divided by some distance. So if we're looking from here to here, we have a change in pressure of 4 millibars, and what we have to figure out is what distance this would travel. So usually there's a scale on the map, I can measure it. So let's say that's, I don't know, 100 kilometers. So your pressure gradient would be 4 millibars divided by 100 kilometers. Okay, so the next one is a Coriolis force. Okay, so since we live on the Earth and the Earth is rotating, it creates a force called the Coriolis force. Now this force depends on several variables. Number one, the speed of the wind. Number two, the latitude you're at. And number three, the Earth's rotation. And the way we're going to deal with this is objects in the northern hemisphere will always be deflected to the right. If we're going from west to east, will always be deflected to the right. Okay, and objects in the southern hemisphere going west to east will always be deflected to the left. And that's going to be our rule of thumb to determine which way the Coriolis force should be thinking. So the Coriolis force here should be pointing this way to deflect this to the right, and the Coriolis force here should be pointing up, so it will deflect it, should be pointing towards the equator, and it will deflect it to the left. All right, so basically the Coriolis force is perpendicular to the velocity of the wind. So the way you can look on this is you can have a non-rotating platform and a rotating platform. And I'll have an activity in class to show you this more, a better idea than just this static picture. But if you just roll the ball to your friend on the other side of the platform, it's not rolling, the ball will roll right to them. But if we rotate the platform, the ball will actually travel a straight path but the platform rotates underneath it, so the guy on the other side won't catch it because it'll rotate straight across, but he'll move away from where he was, and the ball will go off the table. And this is basically the same idea with the Coriolis effect, is when the wind's in the air, the ground underneath it is rotating, and so it gives you the perception that there's something forcing you to the left or right. All right, what is a geostrophic wind? Okay, so basically what's going to happen is our wind, we get our pressure gradient force right here, it goes from high to low, and you get a Coriolis force, especially in the northern hemisphere, that's going to point towards the equator. And so what's going to happen is the Coriolis force and pressure gradient force will start to turn the wind, or start to turn the path of the air, and you get on this path. What's going to change a little more, so your velocity is going to be, at this point, going to be this way. Well, that's going to cause the Coriolis force to point that way. And then this is going to turn a little bit more. That's going to cause the Coriolis force to point this way. And eventually, you'll turn the wind so it's pointing that way. And what actually happens is that you'll turn the wind so much that the pressure gradient force and the Coriolis force will be pointing in opposite directions. And if there are equal forces, what will happen is the geostrophic wind will just have no force that will move it left or right, or I should say here, up and down. It'll just keep going in the direction. And so the idea here is these two forces are equal. When you add them up, they add up to 0. So there's no acceleration anymore to move you towards the low or the high. So you're just going to move in a nice straight line. And this causes the winds to blow parallel to your isobar lines, like we talked about earlier. And those are called geostrophic winds. Okay. What's a gradient wind? The Coriolis force turns the winds caused by a pressure gradient force so that a net force exists. This produces a centripetal acceleration. Around the lows, the net force is inward. Around the highs, the net force is outward. So what does this look like? So here comes our air parcel. It comes in right here, and the pressure gradient force starts acting on it. But to get it to curve around the low, the pressure gradient force has to be the greatest, or the net force has to point towards the center of the circle. Okay, so this causes what is called a cyclonic flow. The air will go what I usually refer to as counterclockwise around the low. And then if you do the same thing with a high pressure system, the net force also points inward to get it to circle around clockwise around the low, and this creates the winds going clockwise around a low pressure system. Also, low pressure systems are referred to as cyclonic flow, and high pressure systems are referred to as anticyclonic flow. So the winds aloft and above the effects of the friction caused by the ground. So as long as we're above what's referred to as the friction layer, we get this circling air around high and low pressure systems. You get two types of gradient winds. You get zonal winds, winds that move parallel to the lines of latitude, so it moves east or west. And then you have meridional winds, and these are winds that move parallel to the meridional lines, which means they blow north to south. All right, so let's talk about frictional forces. All right, this usually only happens to surface winds or winds that are within the first 1,000 meters above the ground. We call that the friction layer or the planetary boundary layer. And what friction does is reduce the speed of the wind and reduces the effect of the Coriolis force. So up in the upper level winds, we get those geostrophic winds where the pressure gradient force is equal to the Coriolis force. And then when you add these together, they'll add up to 0 and the wind moves in a straight line. But when you get a frictional force, what happens here is the winds won't move in a straight line. They'll move at an angle that we call alpha to our isobar lines right here. And that's because there's two forces acting opposite of the pressure gradient force, the frictional force and the Coriolis force, and they add up to be equivalent to the pressure gradient force. And the other thing is the frictional force always points opposite of the direction that the wind flows. So then you have to create your Coriolis force to get the right angle so that these two add up to equal the pressure gradient force. And so in the upper level winds, the geostrophic winds are parallel to the isobar lines, right? They run right in between them. But in the lower level winds, the frictional forces cause the air to flow into a low and the air to flow out of a high pressure system on the surface, okay? So this is another thing you're going to have to know, is the wind likes to flow into lows and out of highs on the surface. All right, so frictional force relationships is the Bailey's law, a relation between wind and pressure. You have upper level winds. If you want to figure out the direction of upper level winds, you stand with your back to the wind. Your left hand side has the low and your right hand side has the high. Now if you want to find the highs and lows in the surface wind, what you do is again apply the same procedure, but you want to rotate clockwise an average of about 30 degrees, and then the left hand side will be your low and your right hand side will be your high. Okay, let's talk about vertical motion. Vertical motion that goes up and down the atmosphere, not motion that goes east or west or north or south. And so we can develop what is referred to as a hydrostatic equilibrium. So the pressure gradient force pointing up is equal to the weight force of the air parcel pointing down. And if that happens, we have hydrostatic equilibrium, hydrostatic equilibrium, where the air partial will not move up or down. And the equation that relates this is your pressure gradient difference here is equal to the density of the air times gravity times your change in height in the air parcel should be equal to your change in pressure or your pressure gradient force. And if these are equal, then you'll get what is referred to as hydrostatic equilibrium, and the air partial will just stay stationary. All right, let's talk about convergence and divergence. What is convergence? Well, convergence is airflow coming together at one point. Like at this surface low here, all the air is going into the low. So all the air is coming together at one point. Well, it's got to go somewhere, and where it goes is up. This is it's not frontal lifting, it's called air convergence lifting. And this will help raise the air and you're at. So it's got to go somewhere. If it doesn't go up, it's just going to pile up, and then the low pressure system will weaken. And so we call that convergence. Okay, but right above the low, the surface low in the upper atmosphere, there's a divergence reading. Eventually this air gets to the top of the atmosphere. It can't go up anymore. It hits kind of like a ceiling and flows out. So you can have surface level convergence and upper air divergence. Now, let's look at a high pressure system. Like we talked before, in a high pressure system, the air is blowing away from the high or outwards from the high. Well, if it keeps doing this, it's going to use up all the air here. So what it does is it pulls upper level air down onto the high, and we call this a divergence. So air is moving away from some point. Now, since this is a surface high, but if you go up above, you get a convergence zone. The air in the upper level winds are converging here because this air is getting pushed down. The upper level air will take up the space that was left behind by this air going down, and you'll get a convergence in the upper level air system. And so this is what we call convergence and divergence. And so usually convergence are associated with low pressure systems, and divergences are associated with high pressure systems. Okay, so here's another way to think of convergence and divergence. Let's do stream flow. Here, when the stream is wide, the flow of the water is slow, but when the stream narrows down, the flow of the air picks up, or the flow of the water picks up. So what we're going to call this is this region right here becomes a convergence zone. So all the air is coming in to this point, so that becomes a convergence zone. And here we usually refer to this as a divergence zone. All the air is trying to get away and leave, and we call that a divergence zone. Okay, so what have we learned today, or should have a better idea about after this online lecture? The forces that influence the winds. You have a pressure gradient force, a Coriolis force, a centripetal acceleration, and a frictional force. Understand how we create geostrophic winds. What are the conditions of the forces that to get us a geostrophic wind? Understand what are gradient winds. Understand how frictional forces can affect the winds in the planetary boundary layer. Understand how we can move air vertically upwards and downwards, and have a better understanding of what we mean by convergence and divergence. I'll see you later, and at